This time, we will take up some of the first n terms of an arithmetic sequence. But before that, do you know this person? Once in his early elementary years, his teacher was amazed how he added numbers from 1 to 100 within seconds only. Really amazing, right? Much more amazing is he did it during his childhood years. He introduced the formula how to find the sum of the first n terms of an arithmetic sequence. He is called the Prince of Mathematicians. Do you know his name now? Yeah, you are right. He is Carl Friedrich Gauss. As our first example, what is the sum of all whole numbers from 1 to 100? So it's like just we will add the numbers 1 plus 2 plus 3 plus 4 plus 5 until 100. Okay, could you imagine that? Okay, so we have the solution. Let's use the solution presented or discovered by Carl Friedrich Gauss, and that is S sub n, or the sum of n numbers or terms, is equal to n over 2 times the quantity first term plus the last term, or a sub 1 plus a sub n. Okay. First, we will identify what are the given. Here we have n, or the numbers are what is 100 because there are 100 numbers there. First term is 1 and the last term is 100. So by just substitution, we can have S sub 100 equals 100 over 2 times the quantity first term 1 plus last term 100. So 1 plus 100 is 101. Multiply that by 100 over 2, which is 50. You will get 5050 for the sum of the numbers from 1 to 100. Okay? What is your conclusion? Therefore, the sum of all whole numbers from 1 to 100 is 5050. Very easy, right? So, actually, you can find out what is the sum of the numbers from 1 to 1000 or 1 to 1 million. Okay, that is easy. Thank you for Carl Friedrich Gauss. Credit to him. Let's proceed now to another. Find the sum of the first 25 terms of the arithmetic sequence 4, 9, 14, 19, 24, and so on. Okay, so how are you going to find the sum? Solution? Of course, we have the formula already. We have S sub n equals n over 2 times the quantity a sub 1 plus a sub n. Okay, so we have the given. Okay, we have a sub 1, which is this one, 4. Okay, so we have a value for a sub 1, but we don't have a value for a sub n. Okay, so we are going to find our a sub n later first before we use the formula for the sum. Okay, so let's proceed now to the given first. What are the given? Our n equals 25 because there are 25 numbers. First term is 4, and our common difference is 5. Why is it that we include the common difference or d equals 5? Because again, we'll find the last term. And in finding the last term, a sub n, what is our formula for a sub n? We have a sub n equals a sub 1 plus the quantity n minus 1 times d. So therefore, we must know what is the common difference, and that is now 5. Okay, so in finding the last term, our last term is what? A sub 25. Why a sub 25? Because we will get the what? The first 25 terms. So therefore, you will only add until a sub 25. So a sub 25 is equal to, the first term is equal to 4 plus 25 minus 1 times 5, and then continue further. 5 times 24 plus 4, your a sub 25 is equal to 120 plus 4. You will get now the last term for this sequence, which is a sub 25, that is equal to 124. Okay. Since uh, we have already the last term, we have now our a sub n. Can we use the formula now for the sum? Of course, yes. Okay. So let's proceed now to the sum. The sum of 25 numbers is 25 over 2 times the quantity first term. What is the first term again? We have 4. And what is our last term? A sub n. We have 124. Okay. So then just simplify this one. We will get S sub 25 equals 12.5 multiplied by 128 to get an answer which is equal to 1,000, 1,600. Okay. So this 1,600 will be our S sub 25. What is our conclusion now? Therefore, the sum of the first 25 terms of the given sequence is 1,600. Okay? Any questions? I hope you got it. Let's proceed now to the third and last example. Find the sum of the first 20 terms of the arithmetic sequence negative 16, negative 20, and negative 24, and so on. Okay, so it's almost the same with example number 2, but this time the terms are negative. So first, for our solution, we are going to recall again the formula for the sum, since we will look for the sum of the first 20 terms. So this is the formula again. S sub n equals n over 2 times the quantity a sub 1 plus a sub n. Okay, so here we have our first term, okay, which is equal to negative 16, and our last term we don't know yet. Okay, so that's why we need to find our a sub n later. What are the given now? Okay, we have the given n equals 20 because we have the first 20 terms. First term is negative 16, and our d, which will be used for finding the last term, is negative 4. Okay, again, since we don't have the last term, we are going to find first what is our a sub n. Okay, to find the a sub n, we will use the formula for finding the nth term. This is a sub n equals a sub 1 plus the quantity n minus 1 times d. So since our last term is a sub is the 20th term, therefore we will look for a sub 25 or a sub 20. A sub 20 is equal to the first term, which is negative 16, plus the n minus 1, 20 minus 1 times negative 4. Okay, a sub 20 is equal to negative 16 plus 19 times negative 4. Okay, I put parenthesis for negative 4 because it's negative. Okay, now let's proceed to simplifying further. A sub 20 is equal to negative 16 plus negative 76. Add them together, you will get negative 92. And this is now your A sub 20. And this A sub 20 will be your A sub n here. Okay? So, let's proceed now to the formula. Okay? The formula we have S sub 20 equals 20 over 2 plus the first term. What is our first term again? Our first term is negative 16. And what is our last term now? We have negative 92. Okay? Just add the first term and last term. We will get negative 108 multiplied by half of 20, which is 10. And multiply them together, you will get negative 1080. So therefore, that negative 1080 will be the sum of the first 20 terms of the sequence. Okay? So what is our conclusion? Therefore, the sum of the first 20 terms of the given sequence is negative 1080. Okay? I hope you learned from this video. Okay? Thank you very much.